All right, here we go. All right, and we're live. Welcome everybody to the first neural audio plugin competition live stream. I'm here with my collaborators Andrew Fife from Cosmo and Christian Steinmetz, and together we've created this this competition as a way of showcasing the exciting things that are happening in machine learning, AI, and neural audio. And what we've done is we've created 4 live stream events that are leading up to the competition. And Christian and Andrew will tell you a little bit more about the competition and the events in just a moment. I'd also like to introduce you to Oli Larkin from iPlug and Ableton, and Valerio Velardo from The Sound of AI, who have joined us for this first live stream. And with that, I will pass it over to Andrew and Christian to tell you more about the neural audio plugin competition.
Thanks, Josh. Yeah, thanks so much, everyone, for joining for the opening event of this competition. And in this kind of short intro at the beginning, Andrew and I just want to give you a little bit of overview about the competition and just to give you some info and hopefully pique your interest if you haven't already been convinced to enter the competition. So as Josh already mentioned, we myself along with Josh and Andrew are organizing this competition with the audio programmer and Cosmo. And we've been working on this for maybe over a year, trying to put all this together and put a lot of hard work into this. And you might be asking, what exactly is a neural audio plugin and why would we host a competition about it? And we've, on our website where we discussed about this, we kind of gave a lot more detail, but I think we kind of have a very broad definition of what we consider to be a neural audio plugin. Kind of the first and most obvious definition, is any kind of audio plugin that uses some sort of neural network components to directly process or generate audio signals. So that can be things like modeling, audio effects or doing synthesis of instruments or speech with neural networks. But I think it doesn't end there. And there's also kind of other ways that we're interested in seeing people develop this, where you could also imagine neural audio plugins could be where you use any kind of neural network to actually analyze the audio and perhaps provide some sort of intelligent behavior, or for example, controlling traditional DSP with machine learning, for example, could be another interesting route. So I would say our definition of neural audio plugin is very broad. And if you have specific questions about that, definitely ask them in the chat or reach out on Discord for clarification. But the other really exciting thing about the competition is that we have many great sponsors that have provided awesome prizes for those that are able to put forward really great submissions. And in our first place prize, we have a cash prize of $2,000, as well as the choice of licenses for either Juice Indie or for Max and Rainbow licenses, as well as thanks to GPO Audio, potential tickets to NAMM and a chance to present your work. In second place, we also have a great prize of $1,000 and similarly a choice for some great licenses. And in third place, we also have an award of $500. So there's should be, really no question about any motivation to enter, as we really want to compensate the participants here for their hard work with some actual valuable prizes, I would say. And so, how the competition is going to work is, right, you're going to make a plugin and submit it. And we're going to have some judging criteria that we use to decide who gets those great prizes. And there's kind of 5 main things that we've looked at setting out to use to evaluate the submissions. One of them is novelty, kind of, are you pushing the boundaries of using neural networks, proposing a new architecture, proposing a new task, for example, doing something very new. Usefulness, are you solving a real world problem or making things easier for music creators? Versatility, can your plugin do many different things and potentially help people in a lot of different ways? Performance, I think, is also an important one. Can it run in real time, which is kind of a requirement for a plugin, right? In many cases. And, where were you able to kind of turn that machine learning into something that was actually able to work in the real world? And finally, character, are you able to have an interesting UI or provide some sort of new way of working with audio that was different with regards to kind of how the plugin was designed. And to help us in evaluating these submissions, we've assembled a panel of a number of people that are qualified to assess the submissions based on these criteria. And so here are our current panel of judges. We have Ale Koretsky from Splice, David Trevelyan from TikTok, and Josh Rice from Queen Mary University of London. So we kind of have people with a lot of experience in industry and experience in research, working with machine learning and with audio processing. So we're also really excited to get feedback on the submissions that you all submit from these great judges. And during the final closing ceremony, when we announce the awards, they'll also provide some of that feedback to the participants on their plugins. So I'm really excited for that as well. But now you might be wondering, I have a great idea for a plugin and I'm working on building it. How do I go about entering this competition? And we try to make it as simple as possible for you to participate in this competition. So the major requirement first is that we require that all the submissions share their code in an open source code repository, for example, on GitHub, and that they also share it under a permissive open source license, so something like MIT or Apache license, for example. And we are choosing to do this to kind of help support further work in this area. So if you make a great submission of making a great plugin, our hope is that if you open source it, other people can build on that, and the community will really benefit in advancing the area, audio development in this area. In addition, beyond the code, though, we also want to see a demonstration video. So you can create a video of 5 minutes, no longer than 5 minutes in length, where you can show like a screen capture of using your plugin in the DAW and maybe discussing some elements of how you built it and what was the inspiration and what it sounds like, I think most importantly. And so you can just upload that to YouTube on an unlisted video if you prefer, and give us that link. And finally, to collect all that information on the webpage, we've already put up this Google form that's super simple, and you just need to give us these 5 things: your email, the list of the team members, a link to that code repository I mentioned, the URL to your YouTube video, and then also just a short discussion kind of on the broader impact of your project, which there's more details about that, but it's really just talking about considering the ethical implications of your work and your training data and things like that. And again, if there's any further questions on these points that I've raised here, feel free to ask them in the chat or to ask them on Discord, and we'll be happy to answer more questions. But I think, and the final thing, very important, all submissions must be received by the end of the day on March 17th, anywhere on Earth. So you kind of have the full time to complete all your submissions. They must be submitted on that Google form. But that's it from me. And I'm going to turn it over to Andrew now to continue the rest of this presentation.
Yeah. Cheers, Christian. Actually, Christian, do you want to just keep up the slides? It's only a few slides left, so I may as well.
I'll keep them up for you.
Yeah. So just going to the next slide. I've just to talk to you about so we have the Discord community now in the audio programmer Discord, and we have a specific special neural audio plugin competition channel that we've opened up just for this. But you might be thinking like, oh, looking forward to this, I want to get stuck in, but I would love to have a team to work on this project, and you might be sort of overwhelmed by like the magnitude of what you need to do, and you might have a specific skill set like in AI audio specifically, and not so much in like the plugin side, and you just want to kind of get collaborating and get part of the discussion with other people. So if you want to join and join in and become part of that discussion, then you can join the Audio Programmer Discord, and we have a specific channel there. We'll keep everything there for you regarding resources, and we can communicate everything to do with the competition in that location. So yeah, be sure to check that out. And we'll go to the next slide. So another thing you might be wondering is, I can't wait to get involved, but where do I start? Like, what's the first thing to check out? What resources are available? And so we've prepared this assortment of resources for you guys, that for you to kind of get up and running, and then a few sort of ideas even to spark some inspiration to get you going. So like I'll just go through some of them here. So we've got the C major framework, which is kind of a up and coming new language for doing like DSP, specifically for audio and real time stuff. So be sure to check that out. We have Juice, which is, you know, famous framework for doing plugin development, one of our sponsors and supporters of the competition. So be sure to check out Juice for building a cross-platform plugin. We have iPlug 2, which is an alternative for that sort of thing as well, building your VST, AU, AAX plugins. We have some SDKs for doing AI specific stuff. So we've got RT Neuro by Jatan Chowdhury, which is a sort of lightweight, high performance inference engine for running neural networks in C++. So be sure to check that out. We also have the Newtone plugin and SDK, which is meant to be for bridging the gap between sort of artists and the researchers. And we actually provide with Newtone a plugin that allows you to run any sort of neural audio model as through this plugin. So you don't say you're a AI engineer, you've got skills in AI and AI audio, and you want to just worry about building a model that you can run in the DAW, and you're maybe participating as an individual, then you could check out Newtone. You don't need to worry about doing any of the plugin development, and you can audition different models at runtime through Newtone. And you can check out our SDK as well on tutorials and resources on how to wrap models for that. We also have MATLAB as well, which they have a mechanism for exporting MATLAB code to VST plugins. You can also build models through MATLAB as well. So it's just another great resource to dive into. We'll go to the next slide. So yeah, today we have up next, we have Valerio and Oli. So I think Valerio's kicking it off today. So super excited to have both them on for the NAP competition. It's a great start for sure. So, and then just lastly, for the last slide, just to highlight, upcoming events. This is just a soft announcement of some of the other live streams that we've got prepared over the coming weeks. So obviously we have Valerio and Oli this week. Next week, we're doing a Newtone workshop for those that are interested in getting up and running with Newtone. The same with MATLAB as well for checking out their toolkit. So we're giving workshops on that. Week 3, we'll have Philip Esling from Arkham who will be on, and Jatan Chowdhury will be talking about RT Neuro. And then the 4th week, we'll have some PhD talks from different students at QMUL, and CG Carr from Dadabots, talking everything neuro audio. And then finally, for the final week, final live stream, we'll have our neuro audio roundtable, where we'll have guests from the industry and academia discussing the current state of neuro audio, where it's going, AI audio, and the future of AI audio. And then finally, the final award and announcement. So that'll be super exciting. And then, yeah, just to kind of highlight our sponsors and the different organizations that have been supporting the organization of the NAP competition. So without further ado, though, I think we're good to get going with Valerio. So I'll pass it on to our first speaker.
Hi, so hi everybody, and thank you very much for having me here. So first of all, I'm going to share my screen. Unfortunately, we tried out my audio, but it doesn't seem to work properly. So I'm just gonna pass you like the links so that everyone like in the chat, I mean like not in the chat, but everyone in the audience can actually like just like follow what I'm like talking about, like when I'm trying to show like some stuff like audio or videos as well. Okay, can you see my screen? Guess so, right?
Yep, you're all good.
Okay, good. Okay, yeah, so in this presentation, I just want to give you a little bit of an overview on generative music, or in other words, generating music with artificial intelligence. And we're going to look into a bunch of different things, but before that, just like a couple of words regarding like myself. So I work like as an AI audio and music consultant, and I'm the host of The Sound of AI, which is like this cool ecosystem with all things about music, AI, audio AI, and sound AI. And I have a background as a musician, classically trained, and as a scientist and programmer as well. Now, onto the talk itself. So these are the different points that I'm going to be touching upon. First of all, we're going to be starting from the difference between intelligent and creative tasks. Then we're going to move on, zooming into generative music or music AI, creative music AI, really. And then I'm going to give you a brief history of generative music and try to give you sort of like a timeline of what's happened over the last 60 years or so. In generative music. And then I'm going to show you some sample generative music systems. And as I said, unfortunately, I won't be able to show you like the audio directly left from my presentation. I'm going to just like share the links with Josh and the others so that they can give access to those links in the chat for you. Then I'm going to discuss some of the challenges that we are currently facing in generative music and talk about the sort of like business impact of AI within the music production, musical landscape. And finally, this is not related to the presentation itself, but I'm going to introduce super quickly the Sound of AI Accelerator, which is one of those initiatives within the Sound of AI ecosystem. As you can guess, this is a music AI accelerator within the Sound of AI environment, but I'm going to tell you all about this like later on. Okay, let's get started. So first of all, we want to start from the difference between intelligent and creative tasks. So here we have sort of like trying to do image classification or even object detection in this case, right? So you have an AI that analyzes, processes an image, and it tells you, okay, so we have a person here, we have a statue here, we have a flag over there, right? And this is like an intelligent task because we have an artificial intelligence that has an objective way of sort of like understanding whether like what it is doing is correct, the answer that it gives us, like it's correct or it's not correct. The same thing like can be said for like a robotic arm, right? So we may use like some AI algorithms to let like this robot arm do really cool things, perhaps like create a statue like by itself or like something creative like that, or something like very, very specific, like sort of like, I don't know, like building a car or something like that, right? And again, this is still like an intelligent task that we can program or we can use an AI to do like this kind of stuff. Another like example of an intelligent task is speech recognition, right? So you have an algorithm that can take whatever you say and then translate it into text. And we have a gazillion examples of speech to text. And now like these systems tend to work actually quite well. Now, what characterizes all of these examples like that I just showed you is that like there are sort of like objective success metrics. So we, as I said, like in the case of object detection, we can say whether like a certain object within an image has been classified correctly. With speech recognition, of course, like we have a ground truth, which is just like the thing that the person has said. So we have an objective way of assessing whether like we have a success or we have failure. Of course, there are gray areas for sure, but all things considered, we have a ground truth and an objective success metric that we can use to iterate upon in order to improve our algorithms. And another point about these intelligent tasks is that they're well defined in the sense that the problem description can be formalized, right? So there is like a formalized way of like kind of like thinking about speech or thinking about objects or thinking about yeah, the different ways like a robot arm can move like within space in order to build something. Now, let's move on to something different, to creative tasks, like, for example, creating a symphony or creating a painting. Well, in this case, we don't have an objective success metric, and this is a big problem, right? Because in order for artificial intelligence to advance, or like any type of venture really to advance, you want to have an objective success metric so that you can iterate upon that and improve based on something that you want to optimize. But how can you optimize a symphony? How can you optimize a painting? That really doesn't make too much sense, because there's a lot of subjectivity involved in the way we evaluate this type of artifacts, creative artifacts. And also, for creative domains, we are talking about domains that are very difficult to formalize. It's very difficult to formalize music or to formalize literature, right? So because of those reasons, there's like a substantial difference between sort of like trying to address intelligent tasks and creative tasks. So artificial intelligence has like a gazillion different definitions, but one of like the main ones is this idea of like building systems that can do rational things. It can do like intelligent tasks using like rational means to achieve the best results possible. Now, computational creativity, we can think of as something slightly different, and we can think of it as a branch of artificial intelligence, which is focused on the idea of building creative machines that can create artifacts that may be deemed as creative by human beings. And so in computational creativity, we try to create or to develop systems that show some degree of creativity, or at least can generate artifacts that we as humans would deem as creative. Okay, so this was sort of like my obsession, and has been my obsession for the last 15 years, really. And this building in particular is where some of this like obsession like took place initially, at least, like when I was doing a PhD here. This is the University of Huddersfield in the UK, and that one there, it was, at least like at the time, my PhD room, where I was sort of like thinking about like these questions. Can machines be creative? Can I reproduce in silico how humans compose music? And how can we formalize the compositional process? And so this sort of journey brought me into generative music and allowed me to sort of like combine the biggest passion that I have. So music on the one hand, and science and programming and artificial intelligence on the other. Now, let's think about generative music itself. So what is like generative music, and what are like the challenges that we have with generative music? And so here I'm trying to give you like a few of like the most important challenges really that we have in generative music. So how can we define or represent music? How can we evaluate generated music? So as I said, there isn't really an objective way of evaluating the quality of the music generated. Also, who should evaluate generated music? Is it experts? Is it like the lay person, or is it other machines perhaps, right? So these are very difficult questions, and there are loads of like lines of research open still today to try to address some of this. Now, generative music is a sort of like very interdisciplinary field. In order to work within generative music, of course, you need to know about artificial intelligence, because of course you're going to leverage many of the techniques and concepts that you have in AI in order to create music. But you also need to know about music information retrieval, because there's a tight connection between analyzing a piece of music using algorithmic techniques or computational techniques, and that is basically the goal of music information retrieval. And on the other hand, analysis is connected with generation. You need to analyze and understand music in order to generate it in the best way possible. But of course, you also need to have an understanding of digital signal processing, especially if you are generating music within the audio domain, which is like one possibility, as we'll see in the remaining of this presentation. You need to know about software engineering, of course, because these systems can become super huge, and you need to be a really good programmer in order to write like code that's reliable and that's scalable at the same time. But you also need to know about music cognition, because if you can leverage that domain-specific knowledge, you're going to be able to steer your programming, your AI skills in a way that makes more sense, and you're going to be able to create better music. And finally, but of course, last but not least, is music theory itself. So you need to have at least a working knowledge of music theory in order, once again, to direct your algorithms in a way like that makes the most sense possible. Okay, so now let's take a look at how we can classify different generative music systems. And there are many ways we can classify them. So first of all, we may ask, what's the goal of the system? So it could be for generating just melody, or for generating chord sequences, or perhaps to create an entire full track, or improvising a jazz line or blues line, or creating loops. But at the same time, the goal of the system is also in relation with the type of music that it generates, right? So you may have a system that generates music for video games, or for movies, or for ads, or absolute art music, or concert music. Another way of classifying these type of systems is to look at the final users. And here we have a lot of different types of users. So some of these systems may be tailored to songwriters, others to composers, perhaps to developers or researchers, or even consumers and users who can play around with them to create their own customized music. Another way of classifying these systems is to ask ourselves, how's the music generated? So what are the techniques that we can use to generate that music? Again, another way of classifying this system is to ask, how is music represented? And regarding music representations, there are two sort of major ways of working with generative music. One is the so-called symbolic approach. The other one is the raw audio approach. I'm sure most of you will be familiar with symbolic music representation, and basically what we're talking about here is using symbols to represent music, symbols that map onto music events. And it could be that you may end up working with a piano roll representation, basically where on the x-axis you have time, while on the y-axis you have frequency or pitch. And so each event within this 2D space basically represents an event of a certain pitch at a certain point in time. But you can also use MIDI or music XML. So all of these are symbolic representation of music, and you can use them to work and train your models in. But there's also another approach, which is the one which is quite trendy right now, and it basically works directly with the signal itself, with raw audio. And the idea is that the moment you work with symbolic music generation is that you have a model, if you're using some sort of machine learning or deep learning, and you train the model with these symbols, and hopefully the model will learn some patterns, and then as inference time, it could be used to generate other symbols that then can be interpreted as music. Whereas if we are in the audio domain, what happens is that we pass in directly audio to a machine learning model, and then we expect audio on the output side. So you would expect directly audio that's generated. So you already get the music completely as a self-contained package, right? Of course, there are ups and downs, or upsides, and downsides, basically, in working with symbolic music versus raw audio music representation. right? In the case of symbolic music, the great thing is that it is like very low dimensional, so it's easier to work with it and for the models to understand larger structures, larger musical phrases and structures, as I said. Whereas in the case of audio, the big advantage is that you're going to be able to directly encapsulate all of those effects and manipulation of the audio signal that in the case of symbolic representation is just impossible to encapsulate because they're completely overlooked, because they are not part of the symbolic representation, which mainly focuses like on pitch, rhythm, and different instruments, but in a very abstract manner. Okay. So the other sort of like question that we had was like, how do we generate music? And I mean, we've used over time all sorts of techniques to generate music. A lot of symbolic AI, like expert systems or generative grammars, and so on and so forth. But also machine learning and deep learning, which has become especially trendy over the last few years. But also like other statistical methods, like Markov models, hidden Markov models, but also like very like algorithmic approaches, like using fractals, cellular automata, and even evolutionary algorithms. So basically, everything you can find within the domain of the field of artificial intelligence, one way or another, has been used to produce music in some shape or form. Cool. If you want to learn more about like all the different like things that have happened over time in terms of like generative music, I suggest you two papers. This one, like the one on the left, AI methods in algorithmic composition, is a great paper to understand a lot about all the more traditional approaches, more like on sort of like statistical symbolic AI side. Whereas here on the right, we have a paper that mainly focuses on more advanced approaches using mainly deep learning techniques. So just like take a screenshot, like if you are interested in this, like these are very, very interesting papers, just like to take an overview of the overall field. Cool. Now let me give you an overview of the timeline of generative music as a field. And I've tried to sort of like divided it into different sort of time ranges, if you will. And the first one is probably like, it's absolutely like the longest one, and it runs from mid-50s all the way to 2010, and that is the academic niche. So at this point, most of the work in generative music has been done in academia, and it was a very niche sort of like subfield of at the crossroads of AI and computational music, computer music, if you will. Then in 2010, we had the advent of a lot of generative music startups, which tried to use many of the stuff like that came out like during like the academic niche period and implement them to create products that people could actually use on the market. And then from 2016, we have big tech coming in and experimenting with generative music. Now, let's zoom into each of these periods, and I'm going to give you like some examples of like the different like systems that have been built like throughout like these periods. So during the academic niche, as I said, there has been a lot of experimentation, a lot of incremental advancements, but most of the time, academics would focus mainly on parts of tracks. They wouldn't generate like the entire track, but rather focus on smaller scope tasks, like for example, generating chord progressions, doing some accompaniment, or generating a drum line. Then there wasn't really any focus on audio production quality at all. It was mainly in the symbolic parts. So the results aren't really that impressive from a production perspective, but there are impressive results indeed from a compositional perspective. The main problem that we had throughout this period, it is like that the community was really scattered all over the place. We had somebody working from computer science, someone else coming from computational musicology, someone else from music cognition. So there really wasn't a community and a forum around which the community could gather. So this was like one of the main disadvantages that throughout like this initial period. So if you're wondering where it all started, from what we know, that is in 1956, when we had a couple of computer scientists who worked on this switch that's called the Iliac switch, which is a string quartet. And if I remember correctly, like this compositions is divided into 4 movements, and within each of the 4 movements, these researchers use different techniques like Markov chains, generative grammars in order to generate a music score. Okay, so unfortunately, I don't think like you can hear this, so I'm just gonna copy the link and hello? Yeah, I'm just like stop sharing for a second.
Yeah.
And yeah, this is the first link. Okay. Yeah, and I'm sharing.
Yes,
once
and
again.
I will paste this in the chat for everybody that's participating in the live stream, and also put it in the video description below.
Okay. Can you see my screen?
Yes.
Yeah, you can see.
Okay. Yeah, I think I have some issues with Zoom anyways, but I mean, like, unfortunately on Linux, Zoom doesn't always work really well. Okay, so I'm just going to move on. You folks can just like listen to the composition while I'm going on. Okay, so here in 2003, we have Continuator, which is a super interesting piece of software developed by François Pachet, a French researcher who's been like really on the forefront of generative music for a very long time, and now he's working for Spotify, I believe. And so this system is based on Markov chains, and it's really interesting because it is able to improvise with you. It listens to whatever you play, it understands what you play, and then it answers. So you create this level of statement and answer, and this continuous improvisation, bidirectional improvisation with the machine. And the result is actually quite cool. So, by the way, here's François Pachet. And yeah, I'm going to copy the link here. And yeah, Zoom is just crashing, so I have to, unfortunately, unshare my screen. Okay, so there you have the link in the chat. Okay, can you see my screen now?
Yeah, all good.
Okay, yeah, good. So now we jump on to 2015, and this is the one of the outputs of my PhD thesis. I built this system that's called S of S of S, and it stands for, it's an acronym that stands for Simulation of Society of Songwriters. So this was a really cool project that I worked on. So basically the idea is to create a society of songwriters where each agent composes and shares music, and the agents evolve their compositional style based on the musical taste of the other agents. So as you can see, like throughout like all of this period, this academic niche period, there's a lot of experimentation, and but none of this really is part of like to build a product that can be put on the market. And this happens for the first time in a kind of like serious manner around 2010, when we start having the first generative music startups. Throughout this product, throughout this period, from 2010 until 2016, I would say, like we have a lot of generative music startups that pop up, and the focus is mainly on products. They mainly focus on full piece generation, And for the first time, there's a lot of attention put on the high quality of the audio generated. And it's the first time that we start having like quite good music data sets as well for generative music. And there are a lot of startups that start relying on machine learning quite heavily. So here you have some of those startups, and some of these startups like exist today still, like Andal, Amper Music. I think like it was bought at some point, but Ava Music and Moobirds are still around. I co-founded Melodrive, and that was in 2016. And so what we did back in the day was creating this cool music engine that could generate music in real time for video games. And the sort of like really cool thing was that the music would adapt to the emotional context of the video game into the narrative. So we shipped a Unity SDK, so an SDK for the Unity game engine, and so that was used by indie game developers. And again, at Melodrive, we also came up like at some point like with cool sort of like prototypes and stuff like that. And one of this like was this Hunter project, which was an artistic VR experience where you had the audio visual components of it, which were both generated in a kind of in a generative manner. And so the whole thing was based on the paintings of Kandinsky, really, and you could jump like from one island, which was sort of like a 3D rendition of a painting of Kandinsky, to another one, sort of like teleporting. And so here we also published an album with some of the music generated, and it's on Bandcamp, and you can listen a little bit like to what we came up with. So now we move on to the sort of like the third period of this timeline, which is big tech experiments. So this starts around 2016, and here we start seeing that there's a huge shift from traditional machine learning techniques towards deep learning. We see the use of massive data sets, massive computational power in order to create these models. And these experiments really don't have a commercial end goal, at least for now, for these big companies. And when I'm talking about like this big tech company, I'm referring to Google and its sort of like creative AI research lab called Magenta, OpenAI, Amazon, IBM, through Watson. And there have been a lot of experiments throughout like this period, one of which is Music VAE, which is a really cool system that has been developed by the Magenta research group within Google. And this is a model that uses variational autoencoders in order to create like cool melodic patterns and to move from one melodic pattern to another melodic pattern in a kind of smooth manner. So let me share once again the link to this video. So yeah, there you go. Okay, and in this video, you can hear that we basically have a couple of melodic ideas. The first one here, at least like I think like you can see the video, that was the first one. This is the second one, and then throughout the video, you'll be able to see how the model is able to move smoothly, like from the first melodic idea towards the second melodic idea. So it's a really, really cool model all around. Now we also had AWS Deep Composer released by Amazon in 2019, and this came out as a way, it wasn't really like a product per se, and it came out in a hardware form. I think like they also like were selling keyboards just like to play around with the model. in an interactive way, but it wasn't really a product per se, but rather a way for Amazon to showcase how cool deep learning, machine learning can be, and the different like potential that it has. And so that's like developers could actually like play around with it quite a lot. And then in 2020, we had Jukebox, which was released by OpenAI. And this is like something like quite revolutionary, I have to say. It generates directly from raw audio. It uses a more sophisticated version of a variational auto encoder that's called a VQVAE. VQ stands for vector quantization. This model is really, really interesting. Let me share this screen here. I'd like to share this link once again. And it's quite impressive because this model is able to capture not just the music style of a certain artist, for example, Frank Sinatra or Elvis Presley, but also to generate the voice of these big artists. And it's quite uncanny to listen to the music generated by this model. It has a lot of problems, like for example, it's not capable of creating a convincing overall structure for the music, and at the same time, the audio quality isn't really there. It's not really that high fidelity, and it has a lot of artifacts, but still, it's quite impressive, the overall result. And now, I just want to inject like this work like that I did with the Sound of AI community. And of course, like it's not big tech, but it's something like that we did in 2020. And I think like it's quite relevant for the competition that you folks have right now. So we basically built like this neural synthesizer, which could be activated with voice commands. Now, let me share once again the link here. Yeah, I'm really sorry for this inconvenience, but I hope it's not too disruptive. Okay, so this was a community-driven research project. So we had more than 150 people sort of like joining and working on this project at different times. It lasted for 1.5 years. People from all sorts of backgrounds and kind of like levels of expertise, which worked together, and we were able to build this cool neural synthesizer with voice commands. This is like the link that I shared, and so here you can see a lot of different examples of the one-shots that were actually generated using these commands. Like, for example, give me a bright guitar, soft acoustic sound. And here you can, down here, you can also hear when you stretch the capabilities like of this synthesizer, that it generates one-shots like that are quite weird, like all around. And all of this research went into a paper that we published last September in AIMT, which is the conference on artificial intelligence, music creativity. Cool. So now we move on to perhaps the final period within this timeline. And I still don't know if this is going to be a new period, but I believe it will be eventually. And I call it the acceleration. And the reason why I call it the acceleration, because I'm noticing that there's a lot of buzz around generative music, generative audio at this point, and I think like that the technology is literally exploding. So we are in the meat of a generative AI revolution. So we all know about ChatGPT, text-to-image generation, like Midjourney, DALL-E 2, and we are at a point where we also start having text-to-music generation, which is a relatively like simple task to understand. So you come up with a piece of text, like for example, a fusion of reggaeton and electronic dance music with a spacey, otherworldly sound. You have a music model, and you end up like with a piece of music that tries like to implement your textual input. Now, there have been quite a lot of models coming out like that do this. For example, one which is like quite famous is called Refusion, which came out, I think it was December last year. So it's a couple of months, 3 months. Okay, let me share this one. Okay, and this model uses diffusion models. Specifically, it was starting from stable diffusion, but then a frozen version of stable diffusion, but then it was fine-tuned on some spectrograms. But we also have other approaches. For example, MusicLM is a quite stunning model. It's based on sort of like sequence-to-sequence representation. So basically, it uses like transformers, and it's a quite complex model because it's made up of many other models. And I have a kind of like quite in-depth explanation of this model, which came out probably 3 weeks ago, something like that, on my YouTube channel, in case you are interested. But the results here are quite impressive, I have to say. By any means, they're perfect, of course not, but they are quite the leap forward, I have to say, all around. And you can just like go to this page and just like try out like some of the of this kind of like music implementations like for yourself. Okay, so when I'm saying I think that we are entering a period of acceleration, is because only in January of this year, so last month, we had, I don't know, like probably then 10, 15 papers with amazing models. And here I just like list 4 of them: Musai, Audio, LDM, SingSong, Rave 2. And it seems like that it's kind of like building up interest like for generative music is building up. Generative music or generative audio more in general is building up quite fast. And it seems like that point in time where not only you have the interest, but at the same time, the technology is there. It's almost there, so that all of this cool tech could be transferred and made into really cool products. But we still have, of course, a gazillion challenges, and music composition hasn't been solved by any means in using like computational ways. So some of the problems. Long-term structural music coherence is still a huge problem. There isn't a single model of the ones that I showed you up until now, which is capable of creating a full piece of music which may be coherent with a structure, with ebbs and flows of tension, and the typical kind of coherence that you get from human-generated, human-composed music, right? The audio production quality is still a big problem. MusicLM has improved on what we had before quite a lot, but still the high fidelity isn't really a thing. So the result can't really be used for sort of like high-end applications, like for movies, for video games and stuff like that. The other big problem that we have at this point is that we still have really cool tech, but it's not really that clear how we can get all of this cool tech and turn it into viable products. And then another problem that I'm starting seeing right now is that some of these systems, like MusicLM, are not just self-contained systems, but they are what I call matryoshka systems, in the sense that they're based on other systems that embed other systems. And many of these models are proprietary. So there is a huge barrier to entry to reproduce some of the best generative models that we have out there. And this point leads us to the final one, which is that given the high entry barrier that we have now for developing this massive generative music models, the risk is that smaller players like research institutions or startups may not compete against the big players. And the risk is that we're going to move into a sort of AI oligopoly where we have like the big tech companies like Google, OpenAI, which of course is backed by Microsoft, which have the necessary money, resources, and computational resources to work on these huge models, whereas the majority out there can't really compute. And this is like something that really worries me at this point. Okay, so now let's move on to the final point of the final section of this presentation, which is how's generative music transforming music? Well, and the other question that we should ask is who's generative music impacting? And for me, we can look at generative music having an impact onto listeners, to musicians, and media creators. If we take a look at generative music and listeners, we can see that one of the ideas is to enhance the listening experience. So in this case, we have an AI system that generates music, and this music is directly consumed by listener. And some of these systems already started back in 1957 with the Onyx suite, right? It's this idea that we can create music that will be consumed directly by listeners. And I think Endel is doing a really good job in this niche because they're not really addressing kind of like high quality music, but more like background music or music, functional music like for relaxing or for sleeping. There are also like a lot of other examples in this particular category, like for example, Bloom, which is like this cool mobile app that has a generative music engine, and a listener can explore an ever-changing music world, and it has been created by Brian Eno. We also had other ideas, again, like in 2018, like for example, the partnership or like the collaboration between Dua Lipa and Jaguar, who came out with The Pace, which is basically like a piece of music which was recombined, remixed dynamically based on Spotify's listeners' profile. So you go to The Pace website, you sign up like with your Spotify account, and then they do a quick analysis, and based on that analysis, they create a new mix which is unique to you based off some music that has been pre-recorded with different instruments and that always has Dua Lipa's voice. I think like this is a terrific use case for enhancing the listener experience. So what to expect in the future? Well, I think we'll be seeing something like text to music models for social media, like in TikTok. So you have like your short video, and then you may want to add music to that, and you can use like a simple text to music model so that you can just like input, like share an musical idea, and then get a musical output that is like very customized like to your need. And we're also going to see personalized functional music, so based on mood, weather, so that it changes. And this idea of interactive albums and songs that change depending on the particular setting that you're in, your mood and stuff like that. I think like this is going to be like something really cool to look forwards to. Then we have generative music impacting musicians, and I think this is all about AI-powered tools for musicians. And here we are within the domain of human-machine interaction, and we can look at multiple use cases, like having some of these tools for inspiration, for enhancement, for facilitating, for example, for being more productive. So imagine you have like a melody system where you pass like a few melodic ideas, and then it develops like a whole melody for you. Then you can fine tune. Also, other systems you can directly collaborate with or practice with. And so some of these systems are going to be really killer for music education. An example of that is Schumann, which, if I remember correctly, was developed at Georgia Tech. And this is a jazz improvisation marimba player. You can see it here. So let me share the link once again here, because this is really like worth watching. There you go. Okay. Yeah, it's quite amazing. Then we have also the Magenta Studio Suite by Google, of course, like the Magenta research unit within Google. And here, these are like all plugins that you can use within Ableton. One is called Continue, so you have a melody, and this melody will be continued by this model. Another one, for example, is called Drumify, so you have like your chord progressions or bass line, and Drumify will just add a drum section for you, which is quite cool. This is another really cool application or model called Onsynth, which is you should know this like very well, because like if you will compete within like the neural audio plugin competition, I mean, Onsynth is sort of like the big like daddy like a neural audio synthesis, really, right? And this is like a really cool synthesizer, and they also, if I remember correctly, yeah, they built like this hardware so that the user could just like set it like and use like this hardware moving like from one point to another to change the quality of the sound. I'm sure you are familiar with this, but nonetheless, for those who are not, I'm going to share this link real quick. Okay, I'm going to share the screen once again. Let's go ahead. So what should we expect in the future for generative music impacting musicians? Well, I think musicians will focus on high-level musical ideas, and then the boring details may be filled in by an AI. So indeed, the boring compositional processes will be offloaded to AI music tools. We're going to have AI music buddies to practice and perform with, just like human. They may be hardware, they may be software, but it's going to be like really cool, I think, like for musicians. And composers will have the opportunity to collaborate with AI tools to be more productive and also to get inspiration. Now, the final point here is generative music impacting media creators. And this is all of these tools which generate music for media. And here we have to create a distinction between linear media, so like videos, movies, or ads, and interactive media like video games, VR, AR, and apps. Boomi is this like cool startup company that you can use just like to create like instant music and share it literally like with the world. And it's overwhelmingly used also like by content creators like to create music like for their videos, for example. There are a bunch of other companies that are doing this. But if we were to look at what's expected in the future, I think like that AI will take over composition for music for videos and ads. I mean, like sort of like all that music that's very functional and it's not really that high quality, probably AI will have a say there. And at the same time, and this is like the sort of the coolest thing for me, AI will enhance composers who score for interactive media, for example, for video games, VR, and AR. This is like a really cool use case, I believe, because it will be possible for a composer to just provide a music idea, and then the actual implementation will be provided by the AI. So depending on how, for example, a video game changes, then the music will go in a direction rather than another one. And finally, we have AI generated music for social media. Yeah, we already saw this for listeners, but this will obviously impact also content creators like YouTubers, but also TikTokers. Okay, some of the generative music blockers that we still have today. As I said, music quality is more or less there sometimes, but not really. And I think there's still quite a lot of suspicion from markets and people towards AI and AI doing creative stuff, even though this generative AI revolution is sort of like kind of removing that blocker for sure. And there's a lot of inertia to change. This is like definitely true if you are talking to traditional companies like music labels. So, but what are in the end the promises of generative music? Well, I think on the one hand, it's music democratization for people and users, consumers. Of course, this doesn't mean that they will become professionals, as they haven't as Instagram hasn't allowed people to become professional photographers. But at the same time, these are tools that will allow people to express themselves and their creativity to a certain extent and have an impact to the music generated. At the same time, and this is the part that is the most exciting for me, I think that generative music will extend what musicians can do right now in all directions, from composition to like the audio quality, sound qualities that they can generate and this kind of stuff. And this is like really exciting. So to wrap it up, generative music should extend what's musically possible, but it shouldn't replace what humans can do already. Okay, so that was the presentation. I hope you like enjoyed it. Like, I'm going to take like questions if there's time for that. But before we get there, I just wanted to say like 2 quick words about the Sound of AI accelerator, which, as I said like at the beginning, it's an initiative within the Sound of AI ecosystem. So this is a startup accelerator that's focused only on music AI, audio AI, and speech AI. So if you want more information, you can go to the website here. You have like all the information on, yeah, I also have like a video where I present most of the information, which is relevant for you. The dates are from April the 11th all the way to July the 2nd. And we accept individuals who are going to form startups, music AI startups, and we're going to teach them all they need to do. We're going to give them like really cool mentors, and they're going to get like industry connections and of course like exposure to investors, and all of this is for free. These are like some of the mentors that you'll have, and I have the honor to also have Josh as one of the mentors for this program.
Woohoo!
Yeah. Cool. And let me just share this final link with you folks. And yeah, and if you want to apply, or just know that applications are open and they will close March the 15th. If you want to keep up to date like with what I do, the Sound of AI, of course, like it's my YouTube channel, you can easily find me there, and these are my contacts in case you want to reach out. So just feel free to take a picture, to take a screenshot here. Okay, so yeah, that's it. I hope it wasn't like too long or too boring, but I really wanted to give a sort of like overview of where we come from when it comes time to think about generative music and where we're going. So I hope like I was able to pass that. Cool.
Yes. Thank you so much, Valerio. There are plenty of questions, some questions that are relevant to this talk, some questions that are a little bit more talking about the competition, but I'll see if I can successfully divide those up. So we actually have a question from George regarding your accelerator. It says, the question is, can one not apply if they have, so I'll read it word for word, and then we'll see if we can interpret what he's saying. One cannot apply if they have already formed a team, started a company, and got funding. What about a solo practitioner, existing company, and bootstrapping? So I guess the question is, does the person, if they've already got started, are they still able to participate in the accelerator?
Of course, they are able to participate, but as individuals, because the idea is to create startup companies there. So if you're a solo developer, for example, but at the same time you are interested in joining up with sort of joining forces with other people and creating a startup company there, then of course you are free to participate, but otherwise no, it doesn't make sense, because the point is to create new startups. Yeah.
Great. Okay. Tugrul asks, I think he says, I think most of the music nowadays is based off of past knowledge of music. I'm not a pessimist, but do you think AI can create a groundbreaking new genre of music?
So this is an incredibly interesting question. Now, so in my research during when I was doing my PhD, one of the sort of more philosophical directions I went into was this idea of thinking about creativity and, well, I should say rethinking creativity. Now, we define creativity or a piece or an artifact to be creative if it's novel on the one hand, and on the other hand, if it brings value to someone. Up until now, we've always been the evaluators, right, of the artifacts that we've created, right? Because there wasn't really other agents that could create creative stuff. Well, that's not entirely true, because we still have animals. Animals, for example, birds, which have their own musical languages in a sense, or whales even, right? And they have their own musical societies in a sense. But now we have AIs. And so I was sort of reflecting on the idea that if we change the evaluator, for example, if we were to create artificial musical taste or artificial intelligences, it could be cool to have agents, AI agents, that sort of drive the development of musical styles, but not having our way of evaluating music. I think this could sound as a quite sort of weird idea, but I think there's something interesting in there, which is that these models may be able to sort of explore ideas as if it was sort of an evolutionary algorithm, a genetic algorithm, right? They would have their own fitness function, their own musical taste, and evolve. And other agents, they would evolve their compositional style. And so if you have a musical taste that's sort of farther apart from our musical taste as humans, but still it makes a little bit of sense, it may be the case that these models may create some new genres that are kind of unheard of. And most of them probably will have zero value for us, perhaps a lot of value for them, because their musical taste will be sort of tailored for that particular genre. But there may be sort of edge cases where we find some new interesting sort of intersections where what's interesting for them at the same time may be interesting to us as well. So you run these models wild, you hear the result of what they create, and then you decide as a human whether it makes sense or not. In that sense, you could use these models to simulate music generation, music society, really, and then take back what makes sense for you. So perhaps in that way, yes, we may see new genres through AIs.
Fantastic. Wesley asks, is there a way to combine the two approaches to generating music, symbolic and using the audio itself?
Symbolic and audio. Up until now, in the majority of cases, you either go audio or you either go symbolic. But there are some papers that I've read back in the day, which were trying to sort of use kind of symbolic, or at least inject a level of music symbolic representation within audio models. And that is definitely a very intelligent and smart idea to explore, I do believe, because it will allow you to lower the dimensionality of audio, which is really, really big. And so it's difficult to create to create long forms that have coherence. Related to that, but it's slightly different, it's also the types of techniques that you use. So right now, all the buzz is on deep learning models, but we are completely ignoring the heritage that we have from symbolic AI. And with symbolic AI, you're able to inject a lot of music knowledge within your models. And that is extremely important, to have something that makes sense beyond a phrase level. In that respect, this is also like another line of research it's not super hot right now, but I feel it should be, and it will be soon, the moment like we start having like less buzz around deep learning, which is neural symbolic integration, which is basically like taking neural models and combining them with more symbolic approaches like generative grammars or like expert approaches, and trying like to combine the two and getting like the best of the two worlds.
Excellent. Tuggerl asks, do you think there will be any innovations using AI on top of Xenaxis, like probabilistic music and other avant-garde, and what other avant-garde composers have done? Do you feel that there will be any differences?
Yeah, of course. I mean, Xenakis wrote some incredible music, I believe, using also like some probabilistic approaches, but they were like very, very simple approaches, and they were like probabilistic approaches. So, and the music that generated was kind of like most of that type of music was kind of timbre driven, really. So it really didn't have that sort of like more traditional structure where you have like a melody, you have a rhythm, you have a chord, a harmonic content, and all of that. In order to develop something like this that's a little bit more traditional, but which at the same time can be pushed in an experimental way, you need to have more control. And a simple probabilistic approach can only bring you so far. So having more sophisticated AI approaches will definitely improve on a simple probabilistic model that works fantastically well for Xenakis type of music or Ligeti type of music, but you can't transfer that to, I don't know, like music for, I don't know, like for video games or the majority of music games. Yeah.
Fantastic. Going back to a question about the accelerator, the man walk asks, is an account on LinkedIn a requirement to join, looking at the application form?
Yeah, we're gonna ask for that. Yeah.
Okay, great. So I think there's one question that could be possibly for you, possibly for the wider group. And I'll just put it out there, and anybody that wants to chime in, please feel free to chime in. Craig Martin says, I see Guitar ML and other products model static snapshots really well of a distortion and amp cabinet processing chain. What would the best approach be for time-based effects like delays, reverbs, or vibrato?
Okay, so yeah, this is absolutely like not my within sort of my knowledge. So I'll just like leave it like to the other folks like to reply.
Okay,
I can give a quick answer on that. It's actually an open research question, I would say. So in my opinion, the majority of work in the neural effect modeling is focused on the kind of like distortion amplifiers and guitar kind of effects that are not time varying. And so actually an open research question as to what is the best approach there. And there are actually a number of PhDs in our lab at Queen Mary that are like asking that exact question right now. So if you're lucky, we'll have an answer for you shortly on that, but it's not yet been published. Yeah.
Fantastic. The other questions are more regarding the competition and things like that. So before I go into those, I wanted to say thank you very much, Valerio, for that fantastic presentation. And what I've done is, for anybody that's curious, I've linked the links that he gave throughout the talk below in the video description. So please feel free to go through those. Some very fascinating research happening in this area, of course. Thank you once again, Valerio. I know that you need to get going. Thank you. And once again, be sure to check out the Sound of AI's accelerator. I will be a mentor for that. And there is a lot of great momentum happening. I know Valerio is going on tour throughout Europe at the moment. So yes, please join him and join his community over at the Sound of AI. Thank you very much, Valerio.
Yeah, thanks a lot, Josh, for having me here. Best of luck. Speak soon.
Thank you very much. All right, take care. Great. So some of the other questions from the community were more related to the competition and just asking wider questions around creating VSTs and audio effects in this space. So one question, which is fantastic because it kind of segues into what we're doing, is from Patrick, and they ask, are there any recommendations for starter projects to apply machine learning to the development of VSTs?
So starter projects, as in like sort of just a get up and running template, is that what he sort of means by that? So we're currently like working on a resource to put out for the competition to facilitate that, which will be great because it will give you a sort of clear example of how to just get up and running with a model that you can either run maybe as part of like Newtone or RT Neuro, which we referenced earlier on. Newtone, for example, is it's got an SDK component and a plugin component where you can actually build models and run them and audition them in the Newtone plugin. So you don't need to actually worry too much about building your own VST, and you can actually build models and run them dynamically through Newtone. So that's one way of doing things. Like the other option is, or another option that's available is RT Neuro, which allows you to train a model and export it to run in C++, which again you can then integrate into a plugin project where you maybe use one of the frameworks, available frameworks like iPlug 2 or Juice to get started there. And there's plenty of materials, obviously, and tutorials on how to get started with these frameworks as well. So there's just a few ways. Like, Christian, do you have any other things you want to chime in with that?
I think that sounds great. And I'm also excited to hear from Oli and his talk, because I think he'll also be giving us another resource to
exactly
add to that list.
to extend from that. Yeah, exactly.
Yeah, exactly. And just to cap on what Andrew and Christian have said, one of the big focuses around this is really trying to help beginners get started in building these audio plugins using AI and neural audio. And that's one of the big focuses on. And one of the things that we had discussed early on is how to do some workshops and some training and help give people some tools. Oli's talk is specifically about that, which is one approach using a plugin framework called iPlug 2, which he will talk about in just a moment. And then next week, just to preview and give a little sneak peek, Andrew and the Newtone team are going to be giving a workshop talking about how to integrate your own models. And Gabriel Bonkaila from MathWorks will also be talking about how to use MATLAB to start creating your own models and how to create plugins using MATLAB. So there are quite a few different types of tools that you can use, and you can also find out more about those tools on the Neural Audio website, the webpage on the Audio Programmer, which I've linked in the video description. And yeah, I have before we jump into the other talk, there's one question from George for Andrew, asking, is the DataBots model included in Newtone?
So we don't have a DataBots model that's included in Newtone at the moment. Maybe it'll be submitted and we can sort of make it public and put it on our online model repository, which is one part of the Newtone plugin that's that we think is quite handy. Is like, you can publish your model through Newtone. It's like available from our servers, and you can like download it, and anyone that uses the Newtone plugin can access it through that online repository, which is built inside the plugin. But yes, I currently don't have a model from DataBots, but maybe they'll submit one, which would be really cool.
Fantastic. And one other thing, just talking a little bit more about how to help other people get started. We have the Discord on the Audio Programmer that is in a special room, a special area dedicated to the neural audio plugin competition. So it's a place for people to get together. So if you don't know anything about the space just yet, and you're excited to get in and team up with people that may know a little bit more than yourself, or maybe you're a good graphic designer, you want to contribute graphic design, maybe you know Juice really well, you want to team up with somebody who knows machine learning really well. We're wanting the Discord to be an area where you can meet other people to do that, and so please feel free to join the Discord. It's the link is once again in the description below. It's theaudioprogrammer.com/community, and join. And if you have any questions, please feel free to ask. One of the things that we've always prided ourselves on is just being welcoming to people that are just getting started. I always say that I'm the eternal kind of beginner in audio programming. So please feel free to come in, ask questions, and offer your skills. And I'm looking forward to seeing what people come up with. And with that, I will go ahead and segue into this talk from Oli Larkin, and he's going to be showing you one way that you can get started with machine learning and getting neural audio and creating plugin. Oli is the lead developer for the iPlug 2 plugin framework and a software engineer at Ableton. And today he's going to be talking about machine learning audio plugins with iPlug 2 and Onyx Runtime.
Okay, 1 second.
Big shout out to DataBots in the chat as well. And if you have any questions during this presentation regarding iPlug 2 and the Onyx Runtime, of course, please feel free to ask, and we will be happy to put those to Oli after the chat, after his presentation.
Okay, hello. Can I just check, are you seeing my slides okay? Great.
Yep, we can see it.
So yeah, thanks to you all for inviting me on here, and I'm pretty pleased to present iPlug 2 and a little, well, I'll get to it, but at the end there's a little template project like what was being discussed, which might be the way that some people who want to enter the competition might like to make a neural audio plugin. So yeah, my talk is about how you productionize a kind of machine learning model in the context of an audio plugin. And yeah, I'm doing this with iPlug 2, which is the framework that I maintain, but you could use the same library with Juice. And in fact, some of the stuff that I've put on GitHub, you could also use in a Juice plugin. So yeah, stay tuned even if you're using Juice. So yeah, I came on Josh's YouTube channel 2 years ago, pretty much this month. So I wanted to do a bit of an update about kind of the iPlug, what iPlug 2, what's been going on with iPlug 2. And the answer is not that much, because I've been working full-time for Ableton for 2 years. But yeah, we've got a few things in the works. For those who don't know, iPlug 2 is a cross-platform audio plugin framework, which lets you spit out lots of different audio plugin formats from the same C++ source code. It can also compile the plugin code to work as a web page, as a web audio module. And we've also just recently been adding clap support. So clap is this new plugin format on the scene. So that's currently on a branch, but it's very nearly ready. Yeah, so we support macOS, Windows and iOS, and Linux is on a branch, but needs some work. And a couple of the nice things about iPlug 2, if you're not familiar with it, it's got a quite fast and nice GPU accelerated UI toolkit included, which is either backed by Skia, which is a very high quality graphics engine, but a very big dependency, or something called Nano VG, which is very lightweight and fast. But there's also lots of other options for doing your UI with iPlug 2. You can put a web view on top of an iPlug 2 C++ DSP layer, or you could do your UI with a native framework like Swift UI or UIKit if you're doing an iOS project. And there's examples included that let you experiment with those things very easily. And yeah, iPlug 2, one of the big things about it is that it has a liberal license, and you can hack away at it, make your own fork, change it however you like. Of course, we really appreciate pull requests and improvements, and people getting involved to help make the framework better for everyone. So yeah, please check it out on GitHub and join our new Discord community. That was one of my points. We recently moved to Discord, which is much better than Slack in my opinion. So yeah, we're there now, and I'll put a link at the end of the slides. Another bit of good news was that we got a not insignificant amount of money via this Google Advanced Web Applications grant, and hopefully that's going to enable us to both me and Alex, my main collaborator, to work on it a bit ourselves, but also to get some other people involved to add some important features like accessibility and yeah, improving the web side of things. Since the money comes from the Advanced Web App grants, we've got to do that, but it's something we wanted to do anyway. But there's a few other improvements, like some shader improvements that's I'm going to land soon, and yeah, CMake and things like this. I just wanted to quickly show a few of the cool plugins that have come out over the last couple of years using iPlug 2, things that I particularly like, before I get on to talking about neural plugins. So this is one which it's a synth. It's called Invader 2 by Onyx, and this is kind of cool to see this come to light, because I was making music using Invader version 1 nearly 20 years ago, and the original version was built using SynthEdit, and now Onyx has used iPlug 2 to make a new version, and I just really like the UI of this and the UX, and it's just a really nice synth. It's a commercial closed source thing, but I think it's quite cheap. The next one is Julian's loudness meter light, which is a pretty cool VST and iPad app. So this is the first iPlug 2 thing to be on the iOS App Store, as far as I know, and it's quite a cool combination of iPad app plus plugin. You can put a plugin in your DAW and visualize all of your various kind of metering needs on your iPad on your separate screen. So yeah, really nice. Another one is this compressor from Hornet, and I just really like the aesthetics of this plugin. I think they use vector graphics really well. Yeah, I mentioned my collaborator Alex. He's Alex Harker, that is. He's recently updated a bunch of open source plugins. They're the His tools, and this is the His tools granular. There's a couple of other ones too, and yeah, you can find them on his GitHub page. They're doing some very nice and interesting kind of audio processing. So the last one before I talk about a neural plugin is this 303 emulator, which is yeah, I'm not so sure I like the aesthetics of this one, but it's pretty cool. It's a web audio module, and Ola Vistet, probably pronouncing his name wrong, has used this template that I made, which lets you it's kind of a starting point template for an iPlug project, which has got GitHub Actions, which will build a web audio module and publish it to GitHub pages. So you can visit the URL shown in the status bar there, and just start playing this 303 in the browser. And it's pretty cool. So as promised, we get onto a neural plugin. And yeah, I just found this project on GitHub a few months ago called Neural Amp Modeler. And I was quite pleased to see that the plugin part of it was using iPlug. So what this is, it's a bit like the Guitar ML project that got mentioned earlier. It's a amp modeler that's based on neural networks, and it's got two components. One is a sort of Python repository for the training of the neural networks, and one is a plugin component. And the developer, Steve Atkinson, has put lots of videos on his YouTube which show him comparing this plugin and his neural network to various commercial offerings. And yeah, they're pretty close. And he's made a Facebook group where lots of people are getting very excited about this and exchanging their own models. So yeah, this allows you to basically profile pedals, and if you've got like bits of amplifier, you can make your own profiles of these things and then load them into the plugin. So yeah, this is the Google Colab that he links to on the part of the repo, or the part of the project that's got all the Python stuff. And this kind of illustrates how people train neural networks. For anyone who's watching who doesn't know about this stuff, I am not an expert in it. I shall declare that now. But he's made an easy mode Colab and a more difficult advanced mode one. But this is basically a Jupyter notebook that's running in the web browser, and it's running connecting to a server which has got a GPU. So it's got maybe 4 cells in this Jupyter notebook, and you can download the kind of input signal, which is like a 20-minute long WAV file of various excitations, and it's kind of like a DI'd signal that you would then run through some kind of process and generate another WAV file, and you can upload your output.wav to the Google Colab file system on the left-hand side, and then you press a button in the Jupyter notebook or the Colab, and it starts the process of training the neural network. And yeah, this easy mode is using a particular model. I think it's, looking at the screenshot, it's WaveNet, and gradually you see that the neural network's accuracy gets better and better and better, and eventually the training ends, and it gives you a .nam file, which is some kind of format that he's put together, which includes the weights for the neural network. So then you can go back and load that into this plugin. So yeah, I saw this project on GitHub, and I gave him some tips on how to use the latest iPlug 2 template to make a better plugin, and to build it all in the cloud using GitHub Actions. So yeah, this is moving on now more to the topic of productionizing machine learning models. And the general workflow with this stuff is separated into a load of tools that get used in research, and then a kind of different mode when you want to productionize things. And a lot of the resources online and the frameworks that are out there are very heavily skewed towards the research side, and it can be a little bit frustrating when you're trying to use these models in a production context, because you find that a lot of it is kind of very linked to Python and the kind of tools that you do research with, you do training with, but not what you want to use when you're shipping a product. So yeah, typically when you're doing the research side of things, you're training a neural network or some kind of machine learning model, probably these days using PyTorch or TensorFlow, but it might also be using a more classical machine learning framework. There's a few of them out there. Scikit-learn is a popular one. You're probably going to export that model at the end to a certain kind of format, and then maybe test that model a bit in Python. Maybe for your use case, you can just use it in Python. But when you want to actually productionize, it kind of depends on the context of what you're doing. But yeah, you're probably going to convert this model into some other format. And then, yeah, a lot of the things that we're seeing that people are very excited about to do with machine learning and AI, they're going to be using cloud-based infrastructure to do inferences on that model. But obviously, we're talking about neural audio plugins here, and that's not really good for us. We want to do inference on the client side inside the DAW in a plugin. So we need to use some kind of inference engine. And yeah, there's various options for this, and it really depends on what your requirements are. So yeah, you could write it yourself, and this is what is going on with the neural audio neural amp modeler plugin, also with some other projects that you'll find on GitHub. You could use a library like RT Neural, which is, it's also sort of yeah, it's written by Jatin, so it's a lightweight dependency, and it's all going to be built into your plugin binary, and it's designed for real time. So this might be the right thing for your project. It's going to avoid you having to link to some third-party library, but it might not contain all of the machine learning operators that your model requires. And especially if you're DIYing the whole thing, like, you might spend an awful lot of time sort of reinventing the wheel and trying to optimize your machine learning models layers and things like this. So yeah, that might not be the quickest option. It might be that you're forced to take that option to DIY, because the machine learning techniques that you're using in your Python models are so advanced that they don't exist in the various runtimes that are out there. But yeah, ideally we'd like to use one of the runtimes, I think, that these machine learning frameworks come with, but they have some problems. So yeah, TensorFlow, if you want to run a TensorFlow model in production, there's a few options that I've investigated. You can actually download a DLL for libTensorFlow, and there's a thing called CPPFlow which lets you interact with it. But this TensorFlow DLL on Mac for an Intel only build is nearly 500 megabytes, which is huge if you're going to ship an audio plugin. And it's also like, if everyone releases audio plugins that are all linking TensorFlow.dll or .dylib, there's potential for conflicts, It's just, yeah, it's got loads of stuff in there that you're not going to be using in your model. So yeah, it might be desirable to use something that's designed more for embedded systems or mobile, such as TensorFlow Lite, which is specifically designed so that you can trim down the size of your inference engine and yeah, make something that's a bit more lightweight. But if anyone's tried to build that, it's not much fun, because it's part of the TensorFlow repository, which is this absolutely massive mono repo. It doesn't have great documentation, and it's got quite a complicated build system using this thing called Bazel, which is used by a lot of Google projects, and it's not as easy to build as, or to use as some other things. Yeah, a lot of people are using PyTorch and Torch script, which is a slightly different process, because yeah, Torch script is, as I understand it, is a way of annotating your Python code and then spitting out some kind of format that will be runnable via the C++ API, linking to the libtorch DLL. But yeah, I downloaded that earlier, and it's also nearly 400 megabytes. Not exactly what you want to ship with your VST, which is probably maximum 20 megabyte DLL or something like this. Yeah, so you've got to bear in mind as well, like if you're going to bundle a DLL with your inside a Mac OS bundle, you might be shipping bundles for VST, audio unit, VST3, and clap maybe, and AAX. So are you going to put the DLL inside all of these macOS bundles? If you're going to like link all of these different plugins to the DLL, that DLL's got to be in a place that's accessible to the macOS sandbox these days. So yeah, ideally, we don't really want to be linking to a DLL or a dilib. On Windows, there's also a bit of a dilemma about where you might put this DLL, and whether you might, if you put it into Windows System 32, I'm not sure that's a great thing to do, because other things might have put their DLLs in that place. So yeah, ideally, we don't really want to depend on a separate DLL, and we'd like to bake all of our machine learning inference into our plugin binary. So that is one of the reasons why I've sort of started experimenting with Onyx Runtime. You can build a dynamic library with Onyx Runtime, but you can also build static libraries. It uses CMake, and it's got a very nice build script and a lot of documentation. So this is a way to make a small library. And yeah, I'm going to talk a little bit more about what Onyx Runtime actually is in a second. But yeah, there was a paper I wanted to mention here at the recent DAFX conference, which is comparing all these different engines. And yeah, I don't want to misquote them, but from their conclusion, it sounded like that Onyx Runtime and TensorFlow Lite were performing better than libtorch and TorchScript. But that might not be the whole story, because perhaps libtorch supports certain operations that you just don't exist in the other things. That kind of problem is something you also have to consider. So yeah, Onyx is the it stands for Open Neural Network Exchange, and I'm just going to read the description here. It's an open format built to represent machine learning models. Onyx defines a common set of operators, the building blocks of machine learning and deep learning models, and a common file format to enable AI developers to use models with a variety of frameworks, tools, runtimes, and compilers. So yeah, the idea is that you can export models from both PyTorch and TensorFlow, and sort of work with one runtime, or sorry, interchange models between frameworks. There's also ways you can convert scikit-learn models to Onyx format. So yeah, Onyx is a separate thing to Onyx Runtime, but Onyx Runtime is something Microsoft developed, which ingests a .onyx format model and performs inference on it. It also says it can do training. I haven't investigated that at all, but yeah, it's a portable C library with a nice C++ interface on top. And it's also got support for things like Swift, and you can compile to WebAssembly. So yeah, you can actually use it in things like Node.js. And I've actually seen a Max for Live device recently, which used a model in Onyx format via the node object in Max for Live, which then you can import Onyx Runtime to your Node.js script, and that in that way make a machine learning based Max for Live device. So that was just an interesting thing. I don't know if that would make it valid for your competition, but yeah, you can use Onyx Runtime in Max for Live. Anyway, as I said already, it's got a very nice build system based on CMake, very good documentation, and there's lots of options for configuring the inference depending on what hardware is available. So you can do inference just on the CPU, or you could use something like Core ML or Direct ML to do hardware optimized inference using the GPU or the various chips that you might have on an M1 Apple laptop that can do machine learning stuff. The way I'm using it at the moment is just using the CPU node. But yeah, there's lots of options for doing inference in different ways. So what I have done is I've built an iPlug 2 template repository, an example, using a model that Steve Atkinson exported from his neural amp modeler Python script. So he converted one of these things to Onyx format for me. And I've built a C++ class around that model that interacts with the Onyx Runtime C++ API in order to load it and perform inference on that. So it's a very simple plugin project. Also can compile to an iOS app or a standalone app on Mac or Windows. And yeah, part of the pipeline is another repo, which is called the ORT Builder. And this is just a collection of shell scripts to build a slimmed down version of the Onyx Runtime that just includes the operators required for your model. So you can put in a .onyx format model into this repo, and the idea is that you run a script. It will convert it to a slightly different format called .ort. Then it will serialize that to C++ source code, and it will also generate a special file called a .config file, which lists all of the machine learning operators that are required in your model, and it will produce binaries. So yeah, originally I was making dynamic libraries of Onyx Runtime, but I had some problems linking that to the audio unit version 3 on iOS. And also, like, whenever you build a dynamic library and try and link it into a VST plugin, you have to mess around with like some RPath stuff. This is all very tedious technical detail, but it's quite confusing, like making sure that your binary finds the DLL on macOS anyway. And what I much prefer is just to be able to link everything statically. So yeah, this repo will build a single static library on Mac and on Apple platforms. It will generate a thing called an XC framework. And this is like a single file that you can drag into your iPlug 2 project, or even to a Juice project. And if you link against that in Xcode, it will statically link to, and it will kind of transparently work for all the different Apple targets. So it supports the iOS simulator, or macOS on Intel, or macOS on ARM. So yeah, that's quite handy. So yeah, the idea is that you include this as a submodule of your iPlug 2 project and use it as part of a CI pipeline, so that whenever you change your Onyx model, it automatically generates the artifacts and then builds them into your plugin. Yeah, so that's kind of the end of the presentation, but I'd be really interested if people experiment with this. And you know, I haven't really tried any really advanced models with this. I don't know how far it's going to get in terms of using the CPU engine, whether we need to do some more sophisticated things like what's going on in the Newtone plugin that was presented at ADC, where I think you were doing stuff on a separate thread. And yeah, at the moment, there's some infrastructure in this example to make sure that the Onyx inference is only working on buffer sizes of 128 samples at a time. It does some buffering if the frame size going to the audio plugin is different, but there's no resampling or anything like that. So that's something to add in the future. So that is pretty much the end of the presentation. Please come and join us on the iPlug 2 Discord if you want to get started. And I'm happy to answer any questions about this template. I haven't quite got it working on Windows yet, because the static library was 2.5 gigabytes, which wasn't great for a portable thing. So yeah, I need to do some investigations to get it working nicely with Windows. I also hope that I might get it working with WebAssembly, because iPlug 2 can spit out a web page, and it would be pretty cool if you could make a neural plugin with the same code that ran in the browser. So yeah, I also have links to all of the things that I've had slides about, and I'll put them in the comments on the YouTube discussion.
Fantastic. Thank you so much. Thank you so much, Oli. That was a great rundown of different options for building your own neural audio plugin, and very educational. I really enjoyed that. So let's see. So we just, not really any questions here, just a comment that says, there's a comment from George that says, if you do figure out how to build the dynamic library linked into a dynamic plugin, I would be very interested in that. And
I do know how to do that. It's just a bit painful, but if you find me on one of the Discord channels that I'm on. We can talk about it.
Fantastic. So that's Architect on Discord. So Architect George, please get in touch with Oli and he can tell you how to do it. So there's another comment from Mr. Damien who says Onyx Runtime is great for doing machine learning and plugins. Super happy that you managed to make it a static library. It was my main issue when I was playing with it. However, Onyx models are not stateful and they do not remember anything from one run to the next. Is there any solution regarding this?
So I think the solution is to add layers which point to extra tensors that you maintain in your C++ code. So if you look at the source code for this LTSM model that I've implemented, there's actually 3 tensors that are passed for input and output, which basically point to kind of scratch buffers that exist in the C++ code. So I think that is how it does the statefulness, if you see what I mean.
Fantastic. This is something I would love to do at some point, but there's a question from Craig that asks, are there any tutorials or courses, free or paid, that introduce a beginner to the iPlug 2 framework? If you'd like to do some tutorials, I'd love to have them on the channel. I'd love to show people how to do it.
It's something that I want to do. I don't have a great deal of time, but yeah, this is on our minds. Something that we might use some of our funding to organize. There is an iPlug 2 tutorial on Music Hackspace, but that is from 2 years ago, so it's a little bit out of date. It's mainly focused on the web-based stuff. So yeah, hopefully we'll improve our documentation and tutorials soon.
Great. Big shout out to JB and Music Hackspace. And let's see, what else do we have? So Mr. Damien commented on your response regarding the statefulness of Onyx models and says, yes, with external states, it works, but for streaming convolutions, it's not ideal.
Okay, I'm a bit of a neural network beginner, so yeah, I'll take your word for it, but yeah.
So I believe that you answered this a little bit earlier with the example that you had linked to using the iPlug 2 framework, but Oliver asks, I've been struggling to imagine exactly how machine learning and/or neural networks are actually used in the context of audio plugins. Do you know of any examples of how neural audio plugins work? So we pointed out a couple examples. There's the work that the Google Magenta project did with using Max for Live devices. There's the plugin that you linked to earlier that uses iPlug 2. Are there any?
Yeah, I mean, I could also add to that. Yeah, I think one example that we've been seeing more and more of in the past like couple of years is this idea of like timbre transfer. So like going from like one input sound and mapping it to like another sound that's based on what the model's been trained on. So like you can imagine like voice being converted to like an instrument or something like that, and that can be obviously useful for exploration and depending on what sort of projects you're doing, like for sound design, for example. So that, I mean, that's one use case, but there's obviously so many other applications as well for it, and for like neural audio mixing and as well. Is like and then also just neural audio synthesis, generating different materials as well using unconditionally from using neural networks. So yeah, there's just a few examples, but there's like many more obviously outside of AMP modeling and things like that. There's lots that can be done with neural networks in the DAW and as part of a plugin.
Fantastic. So this is a great question from Wesley, who says, I'm a Python developer working with AI. How could I contribute to audio plugin development? And I could maybe help answer that. So that's a common scenario that I imagine people have. So there may be people that are great at building plugins using a framework like iPlug 2 or Juice, but want to team up with a person that knows a lot about machine learning, neural audio, or AI. And the Discord group that we have on the Audio Programmer is a great place to do that. It's specifically for these types of collaborations. So don't feel, I encourage you that if you're not an expert in all areas of building I mean, this is a brand new area in audio. So please don't feel intimidated if you don't have it all down and can just pull out a neural audio plugin just with a snap of the finger. This is a competition that's built for collaborations and for people to learn together. So please join the Audio Programmer Discord. I'll put the link in the chat again very shortly. And it's also in the video description, and join us and talk about it. Talk about if you have questions around neural audio, please feel free to join and ask away. So I'll give a couple more seconds for anybody else that may have any questions. In the meantime, any closing question?
I had one.
Thoughts?
Yeah,
Yes.
I had one question for Oli, actually, just like around all the sort of web work that you've been doing. Like, super excited about the prospects of potentially having some neural audio plugins in the web. I'm just wondering, like, from your experience so far working with the Onyx framework and building a iPlug 2 VST plugin or plugin in general using Onyx, what sort of challenges do you sort of foresee or envision with, like, trying to get that compelling to WASM and getting that sort of in the web? Is there any potential things you've seen working with, like, the Onyx framework that you think it could be challenging to get it running in the web like that?
It seems to me like WebAssembly is a kind of first-class citizen part of the Onyx runtimes. Like, they really seem to want to deliver that. So I hope that there wouldn't be any major blockers. So yeah, they provide various options if you build the WebAssembly version. So you can support SIMD in like, it's a very relatively recent addition to WebAssembly spec, I think, is SIMD support. So yeah, there might be some compatibility things, like if your neural network absolutely requires SIMD. Yeah, I don't know quite what the status of that is in terms of browser support, whether it works on like all mobile devices and that kind of thing. So that might be something to think about. Yeah, I haven't actually got to the stage of trying to link the WebAssembly library to the iPlug WebAssembly, and because of the way that you do kind of audio worklets and things in the web audio API, it requires you to have like one part that's quite isolated for the DSP. And in iPlug's case, because we're doing the GUI in C++ as well, there's another bit of WebAssembly for the GUI. And there's certain sandboxing requirements on the bit that runs the DSP, because it's kind of got elevated privileges. It's on a higher priority thread. So I'm a little bit concerned about maybe something in the Onyx runtime WASM wouldn't be allowed in that context, which would be annoying. But I have to find out.
Yeah, and then just another comment, like, I didn't realize that you had a script that allowed you to like essentially export a GitHub IO page from a project, and I'd like to see more published research using web audio plugins, like as part of like a GitHub IO, to demonstrate their work and their research. I think that'd be really cool. And the way forward, I think, to be a lot more interactive with the published research that's coming out.
Yeah, there've been some cool developments lately with like WebAssembly versions of Jupyter notebooks. So you can put sort of interactive Jupyter notebooks in web pages, and yeah, exciting times. So I would like to improve the iPlug web stuff so that you could much more easily embed little plugins everywhere. But yeah, that's time, not enough of it.
Absolutely. Cool. This feels like a great natural place for us to wrap up. Thank you very much, Oli, for that awesome presentation. And
Welcome.
Yeah.
Thanks for having me.
yeah, great. Yes, Christian, Andrew, any closing remarks? Anything else that we'd like to say here? Maybe we could talk a little bit about next week's workshop. So for people, seems like there are a lot of people that are looking to discover new ways to build neural audio plugins, and the workshops next week will focus on that more as well. If you'd like to talk a little bit about that, Andrew.
Yeah, I can say a couple words about that. So next week we'll be doing a workshop on Newtone, which is the platform that we've built at Cosmo, that allows you to train any sort of neural audio model in PyTorch and wrap it with an SDK that we have available, which then has it in a format that can just be loaded at runtime into our plugin. And it runs it as like an audio effect, as well as a sort of synthesis effect as well. That's also an option. So we'll be going through, like, giving a huge like summary and overview of the project as a whole, and running through each component of it step by step. You know, we'll be doing like a tutorial on how to wrap your model. We'll be showing also the resources that we have available with you know, some examples of you know, models that we have, model architectures that we have available that you can train, and then the process of wrapping that model with our SDK, exporting it, loading it into the Newtone plugin, and you know, some examples of some of the community that have been creative with Newtone so far. And yeah, so I hope you tune in for that. I'm sure you'll learn a lot. And you know, for those who maybe like we touched on earlier, have AI audio skill set and maybe lack some of the knowledge in building plugins, it's a great set of tools for someone that just wants to start building models and auditioning them in the DAW and being creative. So that workshop is for you, and for anyone else who's interested in the Newtone project and being part of that community. And then also just to say, like, obviously we'll be in the audio programmer channel as well. If any of you have questions about Newtone, you know, I'll be there, and some of the others to answer and help you. And I think, yeah, we plan to release more resources as well over the coming weeks for you guys to get started, some templates and stuff as well. So yeah, plenty of stuff to come. And then on top of that, just to add, there'll be a MATLAB workshop as well from after the Newtone one, giving sort of an overview of how to build models in MATLAB and build VST plugins using MATLAB as well. So yeah, lots of education next week to come.
Absolutely. And what I'll do very quickly is I'll just show people very quickly the website, just to show a little bit about what we're doing. So big shout out really quickly to the sponsors, TikTok, Cosmo, Juice, Cycling 74, GPU Audio, and MathWorks, who are supporting this and offering up the prizes. And a lot of the common questions that people have been asking, you can find right here on this page. Once again, it's in the video description below. Just asking how you can create a neural audio plugin, how do you submit, when will the competition be held, what are the terms and conditions, an overview of the prizes, and some of the tools that you can work that you can use to create your plugin and the submission requirements. So all of that is on the Audio Programmer website. And Christian, any other final parting words?
Yeah, I think I'll just add a little bit to what Andrew said. I think I encourage everyone to engage on the Discord, like introduce yourselves in the channel. If you know if you're interested, just even a little bit, introduce yourself and look for teammates. I think, as has been mentioned a few times, like this is a great competition for finding someone to work on the ML side and having someone that has someone experience on the VST side. And I think we've kind of heard that today a few times already. I think it's like a great opportunity to get like a power team in that sense. And I think at the same time, I'll also be active in that channel. So like, if you have any question, not just about the competition, but about your idea, like, do you think it's feasible to build XYZ? Like, please ask those kinds of questions. And I'll definitely be trying to answer those and like give people feedback. And if you have like detailed questions or want to hash out an idea, like you can also ping me on Discord and I'm happy to discuss like in detail. So yeah, I'm like really passionate about neural audio effects, and I also have a ton of ideas. So another thing that I'm planning to prepare is actually kind of like to put a list out there of my like half-baked ideas that I have on a list that, don't get to see the light of day. And I just love somebody to take those ideas and work on them. So I'm putting those together as well. And maybe if you're like super interested in machine learning, but don't know where to start, and there were a few questions kind of like that, I hope maybe one of these ideas you could take and see where it goes.
Fantastic. So yeah, join the Discord, join the workshops next week. In the meantime, check out the website and to find out more. Thank you again to Oli and Valerio for presenting. And with that, we will see you next week. Thanks to everybody that tuned in. It's been a really positive response, and we're looking forward to seeing you next week.